Okay, so here are important formulas for the paper 4. So first the chapter is circular motion. The first formula is the linear speed is equal to the length of the arc divided by time, and the angular speed is equal to angle divided by time. So length of the arc is linear speed into time, and theta is equal to omega t. And omega is also 2 pi over the time period, and omega is equal to 2 pi f because 1 over time period is frequency. So that's why the omega is also called angular frequency. It is angular speed as well as the angular frequency. And then the next formula is the relation between the linear speed and the angular speed. V is equal to r omega, and the length of the arc is equal to radius time angular distance theta. I mean L is equal to r theta. And next is centripetal force formula. F is equal to either mv square over r or mr omega square. And the next, in a conical pendulum, if the angle at the top is given, this is the angle displacement theta, and this radius is the linear displacement, then when the tension is resolved into the x component, it is equal to the weight, and its ty component, which is acting toward the center of the circle, is providing the centripetal force. And the length of the pendulum multiplied by sine theta is equal to the radius, because in this triangle, perpendicular over hypotenuse is equal to sine theta. And from this txw, we can write t cos theta is equal to weight. And from centripetal force ty, so t sine theta mv square over r, when t sine theta over t cos theta divided, mv square over r over wmg. So the tan theta is equal to v square over rg, mean the linear speed is equal to rg tan theta product and whole under root. And from this formula, we can write omega is equal to under root g over L cos theta, and the frequency is equal to 1 over 2 pi g over L cos theta. But do remember, if this angle is given, this one here, this angle given instead of this angle, then this tan theta will be equal to rg over v square, because when this tension is resolved, this becomes the ty component and this becomes the tx component. So ty becomes equal to the weight and tx becomes the centripetal force. So that's why the whole scenario is different now. Tan theta is rg over v square, and the omega will be g over sine theta instead of the cos theta, and the frequency will be 1 over 2 pi under root g over L sine theta instead of this cos theta. And the next, in the vertical circular motion, we have to remember that the tension in the string or the reaction at the center is equal to weight plus mr omega square at the bottom, number 1 position. At number 2 position, the centripetal force is independent of the weight, so the tension or reaction is just centripetal force mr omega square. But at the top here, the tension reaction is equal to mr omega square minus mg, means centripetal force minus weight. And again, number 4 here, the T and R are both equal to the centripetal force. And the general formula for the vertical circular motion is tension the string or the reaction at the center is W cos theta plus mr omega square. This is for the vertical circular motion. Now the next chapter is gravitation. So the first formula for the gravitational force, then gravitational field strength at the surface of the planet. Gravitational field strength formula is gm over r square, and this is g and d graph for the isolated planet. Inside it's directly proportional, but outside it's inversely proportional to d. So inversely proportional to d square outside, but inside it is directly proportional to d. And the gravitational potential is minus gm over d, and gravitational potential energy is m times delta phi. Our change in gravitational potential energy will be m times delta phi. Kinetic energy formula is this, and speed is this from this kinetic energy, and the orbit potential energy is minus gmm over r, and The total energy, which is the sum of kinetic and potential, is this. So omega in the orbit is gm over r cube under root. So we can write omega r cube is equal to gm. This is constant. So from this, we can write this Kepler's law T square is equal to 4 pi square gm over r cube. And then we can derive equation v square minus u square 2 times delta phi by equating kinetic energy and potential energy. Mean the change in kinetic energy is equal to change in gravitational potential energy. If the height is greater than the radius, then the potential energy is m phi. If the height is less than the radius, then we can use mgh. Now this escape velocity under root 2 gm over r under root r is the radius, mean the distance of the surface from the center. This is escape velocity. And the next ideal formula, ideal gas, P is equal to nRT, or P is equal to nKT. Small n is the number of moles, capital N is the number of the particles. And this is a formula, this is a relation between number of moles and the number of particles. Then PV over T is equal to constant. We can write P1 V1 or T1 is equal to P2 V2 over T2. Then pressure is equal to 1 by 3 Nm over volume, mean square speed. This is total mass divided by volume, so it can be density. So the mean square is 3 times pressure over density, and the RMS value is 3 times pressure over density under root. This RMS does not depend on the pressure and density because the pressure directly proportional to density. That's why the mean square speed, the RMS speed is independent of the pressure and density. Then kinetic energy is equal to 3 by 2 kT. This is the kinetic energy of the one molecule, and the total kinetic energy becomes 3 by 2 nKT. Mean n is the number of the total particles, total molecules in the ideal gas. So from this equation, we can write that mean square speed is directly proportional to temperature. This is directly proportional to temperature, and RMS directly proportional to temperature under root. So this is a relation between temperature and the mean square speed, and this is a relation between RMS speed and the temperature, sum of kinetic and potential energy of the molecules due to their random behavior is internal energy. In the ideal gas, internal energy is exactly the kinetic energy, and total kinetic energy 3 by 2 nKT. And then thermodynamics, first law of thermodynamics, heat supplied to the system, increase in internal energy, plus work done by the system. I mean, we can write it Q is equal to U minus W, or U is equal to Q plus W. So this Q is the heat energy. It can be MC delta theta. It can be NR delta theta. It can be C delta theta in heat capacity. It can be ML, and the work is equal to pressure multiplied by change of the volume. The next about the temperature and thermal properties. Q is equal to MC delta theta when specific heat capacity given. Q is equal to capital C delta theta when heat capacity is given. And the Q is energy. Energy is power multiplied by time, so power IV into time, so Q is replaced IVT, and this is the loss of energy plus MC delta theta. And here, IVT, energy supplied, loss, plus absorbed by the substance. So from this, the specific heat capacity C is IV delta T over delta M delta theta, or in terms of the heat capacity, it's IV delta T over delta theta. If Q is equal to ML, then heat supplied to the ice, IVT, plus absorbed from the surrounding is equal to ML. So the absorbed from the surrounding can be calculated. Heat supplied, IVT, minus ML, mean which is used in the change of the state. So from this, we can write this specific latent heat is equal to IV delta T over delta M. Next, centigrade plus 273.115 is equal to Kelvin. This is the empirical formula for the temperature in degrees Celsius. So the physical quantity thermal property at unknown temperature minus thermal property at 0 degrees Celsius, then thermal property at 100 minus thermal property at 0 into 100. And then empirical formula for the Kelvin. So temperature in Kelvin, pressure at the required temperature, divide the pressure at the triple point, multiply by 273.16 or 15, it's up to you. So this is empirical formula for the Kelvin. Now come to the oscillation. Simple harmonic motion. If the motion is started from the mean position, then displacement is equal to x is equal to x naught sine theta, mean sine omega t. Then speed is equal to x naught omega cos omega t. And a is equal to minus x naught omega square sine omega t. But if the displacement, this oscillation is started from the extreme position, not from the mean position, then the displacement x is equal to x naught cos omega t, v is equal to x naught omega sine omega t, a is equal to minus x naught omega square cos omega t. All these relations are valid, formulas are valid, only if the system is undamped. There is no loss of energy. So the general equation for the acceleration, A is equal to minus x omega square, where omega square is either g over L or k over m. Omega is equal to 2 pi f or 2 pi over t. V maximum, speed maximum is x naught omega, and V is equal to r omega in terms of the circular motion. Energy maximum is, the total energy is 1 by 2 m x naught square omega square. This x naught is the amplitude. Kinetic energy is 1 by 2 m omega square. And amplitude square, mean x naught square minus displacement square at which the kinetic energy is required. And the general formula for the speed, plus minus omega, under root x naught square minus x square, x naught is amplitude, and x is the displacement at which the speed is required, or velocity is required. So from these two equations, the potential energy at any displacement, 1 by 2 m x square omega square, the point at which the kinetic energy and the potential energy both are equal, exactly equal, that displacement is equal to amplitude divided by under root 2. You can derive it by putting the kinetic energy formula and the potential energy formula equal, and then after cancellation, you can calculate this displacement A divided by under root 2. Next, the electric field. Electric force 1 over 4 by epsilon naught q1 q2 over d square. This is the Coulomb's law. Electric field strength E, this is not energy. Electric field strength 1 over 4 by epsilon naught q over d square. Electric potential 1 over 4 by epsilon naught q divided by d. If we are calculating electric field strength and potential at the surface, then the distance is equal to the radius. Then electric field strength is equal to minus delta v over d. Delta v mean the potential difference divided by change in distance. Work is equal to charge multiplied by voltage. That's why the electric potential energy is 1 over 4 pi epsilon naught q1 q2 over d square. Then in capacitor, q is equal to cv and c is equal to 4 pi epsilon naught r in terms of the charge sphere. Energy is equal to 1 by 2 qv. Energy is equal to 1 by 2 cv square. Energy is equal to 1 by 2 q square over c. And the loss of energy, the change of energy while discharging of the capacitor is 1 by 2 c under root v1, bracket v1 square minus v2 square, mean initial energy minus final energy. And then the discharging of the capacitor is exponential. Its charge is decreasing. Its capacitance is the same. So here we can write Q over Q naught. This is not C over C naught. This is V over V naught. This correction, because Q directly proportional to V. Q is equal to CV. Look at this. During discharging, the capacitance remains same. So Q is directly proportional to V. So we can write either V over V naught or Q over Q naught is equal to T is equal to e power minus T over RC. This RC is the time constant, mean time taken by the capacitor to discharge itself completely, full discharge time. This R resistance, C capacitance. But if the partial charge discharges, small amount of the charge discharges, fraction of the charge discharges, then small voltage is dropped, then this time is required. So Q over Q naught or V over V naught is equal to e power minus T over RC, and the capacitance in terms of the area and D is epsilon naught A divided by D. A is the surface area of the plate and D is the distance between two plates, separation between two plates.